Spears aren't strong enough for you? Can't kill your prey? Try the Atlatl. Power to the Paleolithic hunter.
The first use of the Atlatl was in 30,000 BCE in Europe and marked an important technological improvement. This new device allowed hunters to be further away from prey while also generating more force. The Atlatl arrived in the Americas around 10,500 BCE in the Nevada region and spread through the Americas. They were still in use in 1492 when Columbus arrived in the Americas. The weapon played an important role during the Spanish conquest of the Aztecs. Spanish soldiers reported that the darts thrown by the Atlatl were capable of piercing plate armor. The Atlatl was widely replaced by the bow and arrow, although it is still used today in Australia and many parts of the world. Its use for hunting in the US, however, is greatly restricted.
The Atlatl acts as an extension of the thrower's arm, increasing the force behind the spear as it is released. The very simple design provides a leverage point, called a spur, at the end of a long handle. On some designs, a groove may help to hold the dart in place, and a weight may be added to provide extra momentum. For our recreation, a long handle was carved, along with two resting bars to help balance the dart while preparing the throw. A pen was used as a spur, and was surprisingly effective, likely due to the small pointed tip, which focuses the force quite well. In throwing, the Atlatl greatly increases the acceleration of the dart as it is thrown, since it travels a farther distance in the same time as your arm would normally move in a throw. It also acts like a lever, focusing the force of the arm and wrist rotation into the rear of the dart, pushing it forward. The dart itself flexes during acceleration, storing some of the energy before its release as the dart leaves the Atlatl.
Using Tracker Pro, we started tracking Silas's hand, which was holding the spear. We tracked from its lowest point in the Y direction until release. We chose to track Silas's hand because it was the contact point to the spear. When we graphed the x displacement with respect to time, we fitted our graph with a second-order polynomial. When we take the derivative of the equation fitted to our graph, we get the velocity in the x direction. We can find velocity by plugging in the total time of the throw in for x. We used the same method for the y displacement graph and equation. Once we found these velocities, we found the magnitude to be 8.67 meters per second. Instead of tracking Silas's hand, for this video we tracked the spur because that was the contact point to the spear. We used the same methods for finding the velocity as we did before in the without Atlatl calculations. For these we found the magnitude of velocity to be 12.88 meters per second. From these calculations we can see that when throwing a spear with the Atlatl you get a greater velocity. Having a greater velocity would have been very advantageous to the hunters using the Atlatl. A greater velocity would have allowed more distance in the throw, which would allow the hunter to be farther away from a potentially dangerous prey. With a greater range, the hunters can have more possibilities to shoot prey, whereas with a spear they would have to be much closer and impede their chances of a successful hunt. In addition, if the spear has more velocity, it can cause more damage to the target, allowing the prey to be killed quicker and with less hassle.
The optimization of a spear throw is dependent upon approach, run, release, and braking. For the spear throw with and without the Atlatl, the approach, run, and braking process are virtually the same, thus narrowing the difference in throwing distance to the release of the spear. The release is defined as the start of the spear withdrawal to the instant the spear leaves the hand or the throwing device. The success of the release is dependent upon the angle of release and the angle of attitude. For an optimal throw, the angle of release should be between 30 and 35 degrees. The success of a flight path is defined by the angle of attack, which is the difference between this angle and the angle of attitude. Optimally, the angle of attack should be as close to 0 degrees as possible, meaning that the angle of attitude and the angle of release should be the same. Throwing with an atlatl allows for this, as the angle of release is the same as the angle between the horizontal line and the longitudinal axis of the spear. From our data, it was found that without using the atlatl, the angle of attitude was 34 degrees and the angle of release was 42.6 degrees, giving an attack angle of 8.6 degrees. Using the atlatl, the angle of attitude and release were both 25.6 degrees, giving an attack angle of 0 degrees, thus optimizing the throw.
In an effort to double-check the calculated velocity from the previous methods, we sought an alternative method. During each throw, we used a stopwatch to measure the time of the throw. We then measured the distance traveled by the spear in both trials. The angle was drawn from the still images used to determine the angle of attack. We derived an equation from the projectile motion equations and plugged in our values. The calculated values were higher than the previously calculated velocities. Reasons for this could include lower angles from the second method, as well as inaccurate time and distance measurements.
Using the tracker software provides a large degree of measurement error. Using the same video in different methods, different velocities were calculated. An attempt at tracking the full path of motion proved difficult, as the dart was too thin to see after launch. Further modifications to the spear could include a bright flag for easy tracking. A heavier spear would also more accurately represent the materials commonly used. Javelins used by men in competition weigh 1.7 pounds, nearly double the weight of our spear. Our spear was also capped by a rubber tip, which weighted the end but decreased the aerodynamics. Greater care taken with fletching could also provide better flight, resulting in easier tracking and increased distances.
Further steps could include looking at the efficiency of the bow and arrow. This was the next advancement in weapons technology. Comparisons here could range between a longbow all the way to the compound bow. The arrow itself is often made from a range of materials. Originally, wood was a common source, but now carbon fiber and other materials provide different advantages. The Atlatl serves as a milestone in the evolution of human weaponry and sport. There are many left to discover.
I'm not a film major, Owen.
What?
I am not a film major.
You're not? Oh, geez, I thought I was a film major.
You were you are taking the wrong classes.
Plot twist. There isn't even a film major at this school.
There's a film minor.
There's a film minor. But see, Silas, there's a key difference between the word major and minor.